Oh well, I saw a video of a dude about a pizza. I'll leave a link in the description to the original one. Problem was that you have a pizza and you want to slice it into three pieces. A normal dude would slice like this, then 120 degrees here, another 120 here, so it's 240 degrees of 360, and we have 120 here. So that's even pieces. Shut up. But that's not a mathematical way to slice pizza. Actually, it's not actually comfortable because it's difficult to find a center of a pizza. These Duder introduce the way of slicing like this, and we make these three areas equal to each other. To do so, we have at first look at symmetries that our circle has. Oh, by the way, the diameter is 7 inches, or 7 centimeters, or 7 meters, or 7 units of length. I don't care. So we have symmetries, so we don't need to work with the whole pizza. So we just destroy the bottom part, and actually we have a symmetry here. The left and the right side are equal, so we don't need to work with this part of pizza. So we actually have the quarter circle left only. We want to find this length A. We want to know this we want to know this length of this line of A. So we can the diameter is 14, and we can find A. So this is 2A, this is 2A, and this is 2A. We want to find A, right? The tutor from the video introduced the calculus approach with integrals. That's my dog. With integrals and all kind of stuff. But I think I can use a more geometrical approach to this problem. What should we do? At first, let's draw a normal, beautiful quarter circle. Okay, that's a quarter circle. And our line goes somewhere here. It's our A, right? So let's put a line like this here, and this is our radius 2. So that's our radius 7. I mean, if it's a Cartesian coordinates, it's 7 here, and 7 here also. And this vector is also 7. Its length is 7. This angle is right. 90 degrees. That's our height. So we know that the area of this figure equals a quarter of the area of the central part, and the central part is 1/3 of the area of the whole pizza, of the whole circle. So the area of pizza equals pi r squared. So the area of the red segment, let's say just A, equals 1/3 times 1/4 of pi r squared. From another way, from another point of view, the area of this red part is the area of this sector here plus the area of this triangle. Area of the triangle is 1/2 times A times H, and the area of the sector, I mean of the sector, yeah, it's let me remember correctly. It's this angle theta divided by 2 pi times pi r squared. So the pi's cancel out. We have 1/2 times AH plus theta over 2 times r squared. And this is a system of equations. From this system we can obtain that 1/12 of pi r squared equals 1/2 AH plus theta over 2 r squared. So let's take a closer look at this triangle. These angles are equal. It's angle theta 2 because these lines are parallel. So A equals, holy shit, that's not an A. A equals R times sine theta, and H equals R times cosine theta. What we get? Oh shit. We get that our equation becomes 1/12 pi r squared equals 1/2 sine theta cosine theta times r squared plus theta over 2 times r squared. Right. You can divide by r squared. It cancels out. We have pi over 12 equals, actually that's 1/2 times sine of 2 theta. We get 1/4 times sine of 2 theta plus theta over 2, and that's all. We can multiply it by 4 and get pi over 3 equals sine of 2 theta plus 2 theta. We're introducing a new variable. Let it be he. He equals 2 theta. So that's he and that's he. We get pi over 3 equals sine of he plus he. Is it right? Actually, I don't want to be wrong, but I guess that's right. Oh shit. Looks legit. Okay, fine. Okay. We have to solve this equation. Actually, this equation is not algebraic. It's transcendental because it has sine of he and he itself. But we can use a geometrical approach. We can draw the graphs of these functions. Let's say that this function is f1 and this function is f2 of he, of course. f2 of he. Let it be he, and let here be f of he. So the f2 is just a sine. So it's pi somewhere here. It's 2 pi somewhere here. Sine goes like this. Yep. And this function, f1 of he, f1 of he equals minus he plus pi over 3. It's a linear function. And it's up by pi over 3. So it crosses 0 at the point pi over 3. Pi over 3 is approximately 1 plus something really little. So it's 1. And at this point we've got pi over 3. Uh-huh. And this point goes to pi over 2. And here pi over 3. And our line goes like this. So I've messed up with the scale drawing this graph. So the scale of he axis and f of he axis are not equal. So I messed up with the scales of the axis. They're not equal, but that's fine. So we can see that our linear function crosses our sine graph at this point. What can we do? As I remember, the method of solving this equation, it's numerical, it's not accurate. No, it's like the answer would be close to the real answer, but not equal it. It will be as close as we want it to be. We just have to do as many iterations as we can. Okay. But we have to take an initial guess what an answer would be. So if I take pi over 3 as an initial guess, I have to find the sine of pi over 3, and after that I do the reverse f1 to get an x. Here I get an x, so I get the sine of this x, and then again reverse f1 to get this point, and then sine, and then reverse, and then sine, and then reverse. Okay, so at first I take pi over 3, I take sine of it, sine of pi over 3, and then I take reverse of this function. So the reverse of f1 of he is function such, if we take f reversed of f1 of he, we take just he minus he plus pi over 3. How can we reverse the change? That's actually pretty hard. Well, we multiply by -1 and then add pi over 3. If we do it, we obtain he minus pi over 3 plus pi over 3. Looks legit. It's just he. Okay, let's calculate. So the f reversed of he equals minus he plus pi over 3. Wait a second. It's actually the same function. That's funny. Okay, I take pi over 3. Let's calculate. I take pi over 3. Then sine of this value. And after that I multiply by -1. And then add pi over 3. Bless you. So I take a sine of this value, and again I multiply by -1 and add pi over 3. And again I take a sine of this value and multiply by -1 and add pi over 3. And again I take a sine of this value, multiply by -1 and add pi over 3. Another sine, and add pi over 3. Another sine. We're getting closer to the answer. No. I'm sorry. We take a sine of this value, multiply by -1, and add pi over 3. Take a sine, multiply by -1, and add pi over 3. Take a sine, multiply by -1, and add pi over 3. And so on. And again, I would take a sine of this value, multiply by -1, and add pi over 3. I'm actually a bit tired, but it's science. We get 0.55. So sooner and sooner we get closer to our right answer. Well, let's continue. Sine of this value multiplied by -1 and add holy shit, I'm tired. Let's continue. Sine times -1 and add pi over 3. Sine times -1 plus pi over 3. Sine times -1 plus pi over 3. Well, this method actually converges slowly. Oh shit. This method actually converges slowly, but I hope. Well, I have no hope left. So the answer is somewhere in between 0.53 and 0.54. Let's take the average between these 2 points. 0.53 plus 0.54. I mean 53 divided by 2. So that's our answer. I mean, not the answer, that's our he. He equals 0.535. Now I divide it by 2. Because actually, he is 2 times bigger than theta. So theta equals 0.2675. That's my theta in radians. And I want to find A. So to find A, I take sine of theta and multiply it by r. So, oh no. No. Get back here, yeah. Sine of it. And multiply... The fuck? No. I take this value. Sine of it. And multiply by 7. So, the answer is 1.8550. Well, it's not that precise, it's not 0. It's actually 1.85 plus or minus 0.001. So yeah, if you have a pizza, you find a center, this length is 1.85 plus minus 0.001. So the length of these 3 parts, I mean not these 3 parts, this part, central part. Well, actually I fucked up, it's not 2a, I'm an idiot. I'm sorry. They're different, they're not equal. If they would be equal, the areas won't be equal. But 2a, let's multiply it by 2. Oh my god. A 3.70 plus or minus 0.02. So the length of the central part of the circle is like this. Well, we can obtain these two lengths. How we can do it? We subtract 7 minus 3.7. No, not 7. It's the diameter is 14. We subtract 3.7 and divide by 2. It's 515, and this one is also 515. What the fuck? 515. Okay. That's the end of the video. Thank you very much for your attention. Please do not subscribe. Do not hit the like button. Жопа.